Hi, this is Randy with Sophos Tutor and just want to say thank you for clicking on this video. If you want to support the channel further, please like the video, subscribe to Sophos Tutor, and post all of your comments and suggestions below. Thank you so much. So today we're going to do a series of differential equation problems. So I'll be talking about how we set up these problems, what to look for, and how we solve them. So the first problem we have is, we call this AI, and we're looking for the general solution for dy over dx is equal to 3 sine of 2x. So what we do in a differential equation is we want all the same variable type to be on each side of the equation. That is, we want all the x terms, anything that has an x or dx on one side of the equation, and everything that has a y or dy on the other side of the equation. This is fairly simple here, since we already have most of the x's on one side of the equation. We simply just need to multiply dx to the other side of the equation. So the dx will cancel out, and we will have dy is equal to 3 sine of 2x dx. As soon as you have your x's and y separated, you can now take the integral of each side. So the integral of dy is simply y. The integral of 3 sine of 2x is, well, we need to take the derivative of negative cosine of 2x to get sine of 2x, but because of chain rule, we're also going to have to multiply a 2, which means we're going to need to divide by 2 to cancel it out. And to show that, if we took the derivative of this function, we would get 3 over 2 times the sine of x, or negative sine of x, canceling out the negative, times 2 because of the chain rule, which is cancel out 2, which we get 3 sine of 2x. So this works out. And since we're taking the indefinite integral, we need to add c. So if we clean this up, we should get y is equal to negative 3 over 2 cosine of 2x plus c. And so this is the general solution to the differential equation above. Okay. Going on to II, we have dy over dx is equal to 4 cosine of x over 3. All right, now to solve this, again, we're going to multiply dx on both sides of the equation. So we'll now have dy is equal to 4 cosine of x over 3 dx. We now have x's and y's on both sides of the equation. We will now integrate both sides. Left side will get y. On the right side, we will get 4 sine of x over 3 divided by 1/3. Again, if we were to take the derivative of this function, we would get 4 cosine of x over 3 times 1/3 because of chain rule. The derivative of x over 3 is 1/3. That would cancel out this 1/3. Okay, plus c. And so therefore, y would equal, dividing by 1/3 is the same as multiplying by 3. So we should get 12 sine x over 3 plus c. And this is our general solution. Okay, and so this is 2. Okay, so part B. For BI, 3 dy over dx minus 2e to the 2x equals 0. So we just need to do one extra step. We need to move this 2e to the 2x over to the right side before we multiply our dx. So we're going to just add 2e to the 2x on both sides. So now that will give us 3 dy over dx equals 2e to the 2x. We can now multiply both sides by dx. And in fact, what I'll also do is I'll divide by 3 just so we can isolate the y. So now we'll get dy is equal to 2/3 e to the 2x dx. We can now integrate both sides. As we know, the integral of dy is simply y. The integral of 2/3 e to the 2x, well, we need to copy our 2/3. We then also need to copy our e to the 2x, but then because of chain rule, if we were to take the derivative of this, we would get an extra 2 to be multiplied. So therefore, we need to divide that 2 to make sure that this 2 will get canceled, plus c, which will cancel out that 2. So our general solution will be e to the 2x over 3 plus c. Moving on to part 2. Here we are trying to solve 4e to the x over 2 minus dy over dx equals 0. Okay, so first thing is we're going to actually add this dy over dx over to the other side. Sorry. We will now multiply the dx to both sides. Okay, I'm going to move this around, write the dy first. dy is now equal to 4e to the x over 2 dx. We're now ready to integrate both sides. The integral of dy, as we know, is y. The integral of 4e to the x over 2 will be 4e to the x over 2. Again, chain rule says we were going to get another term multiplying by 1/2, which means we need to divide by 1/2, plus c. Dividing by 1/2 is the same as multiplying by 2. So 4 times 2 is 8. E x over 2 plus c, and this is our general solution. So for part C, we're now going to be solving differentials with trig functions. We have cosine squared of x dy over dx is equal to 3. Okay. Now notice here we have a combination of x's and y's. So we don't want dx in the denominator, so we're definitely going to multiply by dx. That's going to make the right side of our equation the area where we want all of our x's. So therefore, we're going to have to divide both sides by cosine squared of x. So we're going to get dy is equal to, now the reciprocal of cosine is secant. So 3 over cosine squared of x is actually the same as 3 secant squared of x dx. Now we can integrate both sides. Again, the integral of dy is just y. And we have to remember that the integral of secant squared of x is tangent x. If we recall, the derivative of tangent x is equal to secant squared of x. That's our general solution. For part 2, we have cotangent squared of x dy over dx is equal to 1. Okay, we have the same situation here. We're going to multiply by dx on both sides, canceling out. All right. Now, we have another x term here of cotangent squared of x. We can cancel that out by multiplying by the reciprocal of cotangent x, which is tangent squared of x. So we're going to get dy is equal to tangent squared x dx. So now we're going to integrate both sides. The integral of dy is simply y. The integral of tangent squared x is a little bit more complicated. We're first going to turn tangent squared x into sine squared x over cosine squared x. dx. Okay. We're then going to use Pythagorean identity to turn the sine squared of x into 1 minus cosine squared of x dx. So now this is going to equal, we'll distribute the cosine squared of x in the denominator. 1 over cosine squared of x, as we remember, is secant squared of x, minus cosine squared of x over cosine squared of x, which is equal to 1 dx. And now we can integrate both of these terms here. As we recall, the integral of secant squared of x is tangent x, and the integral of 1 is x plus c. And this is our general solution for C2. So hopefully you learned a couple of basic ideas on how to set up and solve your differential equations. We basically want to separate the dy and the dx so that one side of the equation is designated for y's, the other side of the equation is designated for x's. Once we get all the x terms, the y terms together, we can then integrate.